Question number 1, A part. It says factorize the given expression. Now let's see how we are going to factorize it. Now as you can see, there are two terms and we can convert both these terms in square form. So this is 25x square. So you can write it like this: 5x whole square. Here this 16 can be written as 4 square into x minus y whole square. This 5x whole square. Now if two square terms are multiplied, so we can take the square common and multiply them. So this will become 4x minus 4y. Now as you can see here, we are getting here the difference of two squares. This is a square, this is also a square, and we are getting minus sign, so we are getting difference of two squares. So difference of two squares can be factorized in this form: a plus b into a minus b. Now for us, this is a and this is b. So first we are going to write a plus, and then we have b. Then in the second bracket we have a minus b. This is a. Now when you have to subtract b, you will change the sign, right? You are subtracting b, so this becomes minus 4x plus 4y. So now if you simplify in this bracket, you get 5x plus 4x, that will give you 9x minus 4y, and here you will be getting x plus 4y. So this will be the factorization of the first question. Now moving on to the second question. Now if you see in the second question, this is the second question. Now in the second question we have to factorize this expression. As you can see, this expression is in the quadratic form. Now the first basic step of factorization is to take common. So here you can see from these three terms you can take 5 common. So if we take 5 common, here we are getting y square minus 9y, and this will become 22. Now we are going to factorize this. This is a trinomial in the quadratic form, so we are going to split the middle term. Now here the product required is negative 22. As you can see that the product here required is negative of 22, and as the product is negative, so we need to find the difference, and the difference is of 9. So that means we need two numbers whose product will be 22 and the difference will be 9. So the two numbers are 11 and 2. Product of these two numbers will give us 22 and the difference of these two numbers will give us 9. Okay, so what we will do, we are going to split this middle term 9. The rest remains as it is. This is y square. This 9 can be written as 11 minus 2. See, we got these two numbers and we need to take the difference of these two numbers. So 11 minus 2 is 22. So this will give you y square minus 11y plus 2y minus 22. So this will give you 5. Now here from these two terms 11 can be taken common, so you are left with 11. Sorry, y can be taken common, so you are left with y minus 11. From these two you can take 2 common, so you are left with y minus 11. From here you can take y minus 11 common, so you will be left with y plus 2. This will be your answer. In question number 2, we have to solve for x and y. Now these are the two equations given to us, and we have to solve these two equations simultaneously. Now as you can see, the first equation given to us is in the fractional form. So we will try to remove these fractions. Now how to remove the fractions from the equations? Now as you can see in the first equation, if you take the LCM of the whole equation, LCM will be 4. So what we will do, we will multiply each term, left side as well as on the right side, the whole equation. We will multiply each term of this equation with the LCM, and the LCM is 4. So let's multiply the first equation by 4. So we are solving the first one. See, the first term multiplied by 4, then the second term also multiplied by 4. Then moving on to the right side, we will multiply the term by 4, and this last term multiplied by 4. Now when we multiply each term by the LCM, you can see these denominators will be reducing these numerator part. So let's see what equation we are. Opening this bracket with 1. So we are getting 3x minus 6. Now this bracket is being opened with minus 2. So you will get minus 10y plus 8. On the right side you will get 10y minus 12. So collecting these variables x and y on one side, this will become this side, so this will give you minus 10y minus 10y, and these constant on the right side. So we have minus 12 minus 8, and this minus 6 will become plus 6. So you are getting 3x minus 20y is equal to minus 14. So you can see the first equation that was in the fraction form has been reduced, and we have got it in the simplest form. So this is our equation number 1. So here we have converted it into the integer form. We have removed all these fractions here. Now moving on to the second equation. In the second equation, if we take the LCM of the whole equation, you can see we have 4, 8 and 3 as denominators. So LCM will be 24. So here we will multiply each term of the second equation by 24. So let's multiply each term by 24. So 24 multiplying the first term, then 24 multiplying the second term, then 24 multiplying the third term, and on the right side we have these two terms, so multiplying them with 24. So you can see we have multiplied each term of the whole equation with the LCM. So as you can see, these denominators will be reducing this LCM part. Now we will open the bracket. So first bracket opened with 6. So this will give you 6y minus 6x plus 3x minus 56x plus 40y, and on the right side you will be getting 24y minus 48x. We're collecting all the variables on one side, so we have on the left side see minus 56x and then minus 6x. This will make it minus 62. Minus 62 and plus 3 will make it minus 59x, bringing this minus 48x on the left side, so it will become 48x plus. Now the second variable y, on the left side we have 40y plus 6y, that is 46y, and collecting this term minus 24y is equal to 0. So this will give you minus 11x, and this will give you plus 22y is equal to 0. Now you can see we have removed the fraction from the second equation. Now this whole equation can be reduced by 11. So if you reduce it, minus x plus 2y is equal to 0. This is the second equation. So here we have got the two equations given to us. They were in the fraction form, we have converted into the integer form. So let us solve equation number 1 and 2 simultaneously. Now we know three methods of solving these equations simultaneously. One is the substitution method, one is the elimination by making the coefficients same, and the third one is cross multiplication method. So you can apply any of these three methods to solve these two equations. So the first equation was 3x minus 20y is equal to minus 14. Second one is minus x plus 2y is equal to 0. Now here what I will do, I will try to make the coefficient of x same. For that, x is having the coefficient number 3 in the first equation, so I will multiply second equation by 3. And in the second equation the coefficient number for x is 1, so I will multiply the first equation by 1. So my first equation remains as it is, 3x minus 20y is equal to minus 14. Second equation is multiplied by 3, so minus 3x plus 6y is equal to 0. X having the same coefficient with opposite sign, so we will add these two equations. This will cancel out, so we will be getting minus 14y is equal to minus 14. So this will give you value of y. The value of y is 1. So okay, we have got value of y as 1. Now substituting this value of y in equation number 1 or 2. So I am substituting into equation number 2. This is equation number 2. In this equation I will be substituting value of y, and it's 1. So this will give you x is equal to 2. So we were asked to solve for x and y. So value of x we are getting 2 and value of y as 1. Now if you go through the question, you can see you have been given a square plus b square, and we need to find a cube minus b cube. Now remember, if you have to find a cube minus b cube, so to find a cube minus b cube, you must know a minus b, right? See, the question says you have to find a cube minus b cube. So to get a cube minus b cube, first of all you must get a minus b. Okay, so we will try to find a minus b, and what's given to us is a square plus b square, and they have given us a square plus b square, that is given to us. Now see, the question says with the help of a square plus b square you need to find a minus b first of all, and then after finding a minus b, then you can find a cube minus b cube. So first of all I'm going to use the formula a minus b whole square, because I need to get a minus b first. So it will be a square plus b square minus 2ab. Okay, now here a means x and b means 1 upon x. So a means x and b means 1 upon x. Okay, substitute it here. So this will become x square plus 1 upon x square minus twice a means x, b means 1 upon x. So you will be getting x minus 1 upon x whole square is equal to x square plus 1 upon x square minus 2. Okay, now x square plus 1 upon x square is known to us as 18. So this will be written as 18 and then minus 2. So x minus 1 upon x whole square is equal to 16. Now taking the square root, so you will be getting x minus 1 upon x is equal to square root of 16 will give you plus minus 4. Remember, taking the square root you will get the result as plus minus 4. So as the question says, we have to find a cube minus b cube. So first of all we need to get a minus b. So we have got a minus b. Now we need to find a cube minus b cube. So to get a cube minus b cube, what we will do, first we will apply the formula a minus b whole cube. This formula will give us a cube minus b cube minus 3ab into a minus b. This is the formula. Now as from the question we know that a stands for x and b stands for 1 upon x. So let's substitute over here. X minus 1 upon x whole cube. This will give you x cube. This is 1 upon x cube minus thrice a into b, x into 1 upon x, and then a minus b. So this is x minus 1 upon x whole cube is equal to x cube minus 1 upon x cube. X will cancel out, so minus 3 times x minus 1 upon x. Okay, now if I transfer this term minus thrice x minus 1 upon this side, so it will become plus thrice. So see what we have done, we have arranged formula for x cube minus 1 upon x cube, because according to the question we have to find x cube minus 1 upon x cube. So first we have arranged the formula for it. Now here we will substitute value of x minus 1 upon x to get value of x cube minus 1 upon x cube. Now as x minus 1 upon x has two values, plus 4 and minus 4, so we will solve two cases. In case 1, we will consider x minus 1 upon x as plus 4. Let us substitute the value here as plus 4. So in this formula we will substitute value plus 4. So this will be 4 cube plus thrice of 4, and in this way we will get value of x cube minus 1 upon x cube. This will give you 64. This will give you 12 x cube minus 1 upon x cube. So the value for x cube minus 1 upon x cube will become plus 76. This is case 1. Now we will go for the case 2. So what we will do in case 2, as you can see, value for x minus 1 upon x is equal to minus 4. Now in the same formula you will substitute value as minus 4. So minus 4 this will give you minus 64. This will give you minus 12. This will give you minus 76. So the question have asked to get the value of x cube minus 1 upon x cube. So these two will be the result, positive 76 and negative 76. Okay, now in this question we need to prove that AP bisects angle A. Now AP will bisect angle A only if when we are able to prove that angle PAN is equal to angle PAM. If we are able to prove that these two angles are equal, then we can say that AP will be bisecting angle A. Now to prove these two angles equal, you can consider these two angles, they are the part of these two triangles. So let us prove congruency of these two triangles. So first of all we will consider triangle PAN and triangle PAM. So first of all we will try to prove congruency of these two triangles. So let's see how can we prove the congruency of these two triangles. So we have the two columns of statement and reason. Okay. Now in these two triangles, first of all you can see that PN is equal to PM. This is already given in the question that PN is equal to PM. This is given. Second thing, you can see that angle PNA and angle PMA both are of 90 degrees, so we can say they are equal. Both are equal to 90 degrees. And one more thing, you can see that AP is the common side. So AP is equal to AP being the common side. So proving one angle of, showing one angle of 90, then AP is the hypotenuse. We have shown hypotenuse is also equal and one of the side is also equal. So by RHS we can say that the two triangles are congruent. So here we have used the property RHS. Now let us see the corresponding parts. Now the corresponding parts will be whichever sides have been shown equal, angles opposite to them, or whichever angles have been shown equal, sides opposite to them, they will be the corresponding parts. Okay, so first of all we can write that the side, as you can see, two sides are equal and congruency has been proved. So third side will definitely be equal because two sides have been shown equal as well as congruency has also been proved. So we are confirmed that the third side will also be equal. So here we can simply write that AN is equal to AM. Remember, on showing two sides equal and also showing the congruency, then only you can say that the third side will be equal. Okay, next we can say the corresponding part. As you can see, these two sides are equal, so angles opposite to them will also be equal. So angle PAN is equal to angle PAM. And then we have the third angle, that is angle NPA is equal to angle MPA. So these three corresponding parts have been shown equal by CPCT. Now writing the name of the two triangles in the sequence order. So we have vertex N, then we have vertex AP. So we can say triangle NAP is congruent to triangle MAP. We have M, then we have A, then we have P, MAP. Okay, now moving to this part, as you can see, we have shown angle PAN is equal to angle PAM. So once we have shown that these two angles are equal, which two angles? We have shown these two angles are equal. So when we have proved that these two angles are equal, we can say AP is bisecting angle A. So our final statement will be, as angle PAN is equal to angle PAM, so therefore we can say that AP bisects angle BAC. This is how we will be proving it. So this was the solution to the class test that was conducted on the 8th of July. Hope this is clear to you now.